Welcome to the screencast of 6.4, Exponential Growth and Decay. So in previous years, you were given the formulas, but here we're going to come up with the formulas, all right? We're going to come up with the equations that you've been using for a while. Okay, so a differential equation, dy dx, is equal to fx gy, blah, 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 is said to be separable. Okay, so notice that this kind of looks like what we've been doing before. All right, the difference is if I scroll up here, I have a differential that's equal to a function in x. All right, so dy dx, I have a differential equal to a function in x. Now the difference is 6.4, we have both a function of x and a function of y. That's why it's separable, because we have a function in x and y. Oof, okay. So in order to solve this, we're going to move dx to this side, and I'll move the gy to the other side. Okay, so what I'm going to be doing, all right, I have dy dx, let me just show you, is equal to fx gy. All right, so if I multiply by, let's see, dx on both sides, I have dy is equal to f of x times g of y dx, and then I'm going to divide by g of y on both sides. So I'll have 1 over, I'll show you, dy over g of y is equal to fx dx. So now that I've separated the variables, right, that's why it's separable, is because I can separate the x and y variables. All right, so I literally will have 1 over g of y times dy is equal to fx dx. Now, the last thing to do would be to take the integral of both sides, and that's what it's showing down here. So the solution is found by anti-differentiating each side with respect to its thusly isolated variable. Right? So on the left I have y's, on the right I have x's. Awesome. Okay, so let's go ahead and let's do example 1. Use separation of variables to solve the initial value problem. Here are my initial values. Indicate the domain over which the solution is valid. So the first thing I'm going to do is multiply by dx on both sides. Right? Dy is equal to x over y times dx. And then I'm going to divide by y. Oh, I'm sorry. I'm going to multiply by y. So I have y dy is equal to x dx. Now that I have it separated, I can take the integral of both sides. Now this is going to be a little different, right? Because technically this is x to the first, y to the first, so add 1, divide by its new exponent. So I have y squared over 2 is going to be equal to x squared over 2 plus c. So remember, this is x to the first plus 1 over our new exponent, okay? And then, so technically this is, plus c1, this is plus c2, and then I showed you how to move the constants over. Whatever, I'm only going to have one constant, right? A constant plus another constant. Okay, whatever. It's just going to be a number, a constant. Cool. So I have this equation, and now I'm going to take my initial conditions and plug in. So my initial y is 1. So I have 1 squared over 2 is equal to 2 squared over 2 plus c. So this is just going to be 1/2 is equal to, let's see, 2 squared is 4, 4 over 2 is 2, plus c, so minus 2 on both sides. Negative 3 over 2, so negative 1.5 is going to be my c, right? So plugging all in, y squared over 2 is equal to x squared over 2 minus 3 over 2. We need to solve for y. We need to isolate and get y by itself so I can tell you the domain over which the solution is valid. So get y by itself. First step, multiply everything by 2. Next, square root. So the issue is, since I'm taking the square root, I'll have plus or minus this x squared minus 3. Now think, how would you know whether it's plus, is it minus? Oh my gosh, Okay, so we know it's going to be the plus because we look at our initial conditions. All right, initially y is 1 and x is 2. All right, y is 1 initially, x is 2. So I need to make sure it's valid. All right, plus or minus. Let's see, 2 squared is 4 minus 3 is 1. So clearly this has to be the positive one because I have a positive y. So I have y is equal to the positive root x squared minus 3. Okay, so we found, so we've separated and we have y, but now I need to talk about the domain. All right, so if you put this into your calculator, all right, you'll notice that this is what the equation looks like. But if you didn't know, all right, you know whatever is under a square root has to be greater than 0. So if x squared minus 3 has to be greater than or equal to 0 because you can't have a negative under a square root. So x squared is greater than or equal to 3. So when you take the square root on both sides, you'll find plus or minus 3, right? So if I said x squared was equal to 3, you would see x is equal to plus or minus root 3. Now x has to be, so those are the 2 points where x is 0. And then knowing that, okay, if I plug in like, 0 under here, well, 0 minus 3 is negative because it's either between them or it's going to be on the other sides of the positive and negative 3. So we write out the domain as negative infinity to negative root 3 union, let's see, I want to include because it's or equal to, right? Or equal to, so okay, so I'm going to include union root 3 to infinity, and that is the domain. Right, I look at my graph, I see that my lines are, going to negative infinity and positive infinity from our negative root 3 and positive root 3. It's definitely not the values in between because there's no function there. Okay, let's do the next one. All right, dy dx is equal to xy squared when y equals 1 and x equals 1. So the first thing we're going to do, I'm going to write this as, let's see, I'm going to write this as dy dx is equal to x squared y squared. Okay, just to make sure we distribute this to both, I get 1 over y squared dy is equal to x squared dx. All right, divide by y squared on both sides, multiply by x squared. Take the integral of both sides. So maybe I should have left this as y to the negative 2. All right, this is y to the negative 2, so if I add 1 to the exponent, divide by our new exponent, so this is just going to be negative 1 over y is equal to, so you add 1, divide by our new exponent, x cubed over 3 plus c. Okay, plug in our initial values. So I have negative, well, 1 over 1 is just negative 1, equals, let's see, x is 1, so 1/3 plus c, subtract 1/3 on both sides. I see negative 4/3 is going to be c. All right, so I'm not gonna show you the fractions, you should know how to do that. All right, so I have negative 4/3 is c, so I have negative 1 over y is equal to x cubed over 3 minus 4 over 3. If let's see, I can flip, right? If I flip both the top and the bottom, we've done that before, right? Flip the tops and the bottom. Well, I should probably show you one more step. Okay, so negative 1 over y is equal to x cubed minus 4 all over 3, right? They have the same denominator. Okay, so I can write this as negative y is equal to 3 over x cubed minus 4, right? Multiply both sides by negative 1. So I have negative 3 over x cubed minus 4. And I don't have two options this time. This is the only option I have. And the only x value I want to cut is the one that makes x cubed minus 4 equal to 0. So x just can't equal the cube root of 4. So that's chill. I will just write, as long as x is not equal to the cube root of 4, we're going to be Gouda cheese. We'll be good. Okay, let's try the next one. So I'll split it, and this will be 1 over y dy is equal to 2x dx. Take the integral of both sides. Okay, so I get, this is going to be ln of absolute value of y is equal to, let's see, this is 1, so add 1 to the exponent. This is y to the lower first, plus 1 to the exponent, divided by our new, so that goes away, x squared plus c. Okay, if I plug in y is 1, so ln of absolute value of 1 is equal to, let's see, x squared, so 2 squared plus c. ln of 0, ln of 1 is just 0, so you have 0 is equal to 4 plus c, so c is going to be negative 4. All right, so I have ln of absolute value of y is equal to x squared minus 4. I would like to put each side, e to the power of ln of absolute value of y is equal to e to the x squared minus 4. Okay, so what you get, oops, oh my god, what? Okay, so what you get is the absolute value of y is equal to e to the x squared minus 4. And the reason, right, we had the absolute value, so I have to leave the absolute value. So we're not done. We can't just leave it as absolute value of y. Really, think about what absolute value means, right? If I have like, absolute value of y is equal to 5, that means there's two solutions, right? Because absolute value is just how far away you are from 0. So it could be -5, it could be +5. So this just means plus or minus. So y is going to be plus or minus e to the x squared minus 4. Now the issue is it plus, is it minus? Which one do we choose? Well, you look at your initial conditions, right? You plug these in. So if I pick the negative side, right, negative of this whole thing, that can't be true because y is +1, so that's why it has to be the positive. Because when I plug in 2 for x, right, let me plug in 1 for y and 2 for x, plus or minus 2 squared minus 4, so it's just e to the 0, which is 1, so 1 has to be either +1 or -1. Okay, it needs a match, so it has to be the plus. That's why it's okay. So this means y is equal to e to the x squared minus 4. Okay, another way to write this is going to be e to the x squared over e to the 4. And this is the way like your book would write it. Either answer's right. Maybe I prefer this one a little more because it's more of an intermediate step. Hopefully you definitely can get to it. Because if you think about it, if I take e to the x times e to the 4, this is just e to the x plus 4. If I have e to the x over e to the 4, this is going to be e to the x minus 4. So that's how I knew how to turn this in, right? The minus, if I have, e to the x squared over e to the 4, this is just going to be e to the x squared minus 4. That's how I know how to write it. Okay, so what else do I want to say about this? That is our solution. Awesome. That is our solution. This is where we'll end the first part of 6.4 screencast. The next one we'll finish out the rest of the notes.